our volume chart is prepared, okay, for the foundations.
Okay.
Okay, so volume chart, how it looks like, I'll show you. Give me a second. Okay, I'll show you. No worries. So I will show you the soil investigation report also, as well as you can see my screen, right?
Mm. Yeah.
So see, the soil investigation report will come in this way. It is report on geotechnical investigation for railway electrification. So this is done by some company, GeoInfra. So these are specifically for this purpose. Okay. So this will be like long things, long marking things. So we don't need to read those things. It's just the document that we need to submit. See here, where they have taken the sample, that also it will be written over here. Okay.
Okay.
So the report look in this way. See here, first what it will come like, it will show like first sandy slit with clay, then clay slit with intermediate plasticity. So these all things, the composition they will tell. Here you can see at this particular kilometer, for example, this is our like naming of the kilometer, you know it, right? 390 kilometer, 390 of 4. Okay, so here it's showing like as a normal soil. So how it is showing for 1 meter depth, what is the recommended safe bearing capacity? This is very much important. Okay, you have to see this one, bearing capacity. If you go 1.5 meter deep, it's showing this much. 2 meter deep, it will show this much. 3 meter deep, it's this much. Then at this location 392, after like 2 kilometers approximately, you will see that sandy type of soil. Okay, so this can change. Here you can see the black cotton soil. So as you go forward like 2 kilometer, 3 kilometer, the soil type can change. Okay, so they do in that way only. So every 2 kilometer they are doing, say approximately 2 kilometer, or else wherever they feel like there can be some change in the soil, this will be done. Okay, any doubt till now?
This is there is written D safe recommended D recommended safe bearing capacity. Okay,
Recommended
let
is like DED, it was so D1 it came down. So it's
okay.
recommended safe bearing capacity kg per meter square. Okay, so after this you can see this volume chart, it has been prepared. See here, this is index 1, but here you should go and see what is the soil recommended safe bearing capacity. It was written no, kg per meter square. It is over here. If it is up to 11,000, uh, according to our need, I will tell you how to choose the FDN code, how we are choosing FDN code. But for now, you can just imagine that if, for example, we are using for 135, then we will be going for if it is 11,000 soil bearing capacity into this test. Okay, this is the test done, no? So in that it has been telling somewhere around 11,000 or else somewhere around 10,450. So what we will do, we will go over here. Okay, we'll go over here and we will see that it is 11,000. So we have to take the next higher thing. Okay. If it is 11,000, but it was what? Black cotton soil.
10th. Yeah.
Yeah. So this you should go over here. So this is a black cotton soil, pure gravity foundation, black cotton soil, wet black cotton soil. And this is pure gravity, side gravity soil, side bearing. This is a normal one. Basically, we go for this one. Okay. If it is a normal, but if it is a black cotton soil, then it is till 11,000. So 11,000 we are taking. So somewhere here we will take, we'll go at this location and we will then decide the FDN code. Okay. Like that, we will go and we will assign it, because here the design is there of the foundation. Okay. If you go for B3, as I told, so the A dimension will be this much, B will be this much, C will be over here. You can see C will be here and H will be the height of. Okay. Are you getting?
Yes, yes.
So like this, they will select the code and they will, that means we'll write in the drawing only B3. Okay. So on
Okay.
the side, they will check this B3 मतलब क्या है.
Okay.
तो वो लोग ये इसका ये मतलब ये साइज का फाउंडेशन करेंगे. तो वो फाउंडेशन कैसे दिखेगा आपको? इस तरह से दिखेगा. ओके. और ये लगभग इस तरह से फाउंडेशन होने के बाद ये वैसा फिनिश्ड फाउंडेशन दिखेगा. पर हाँ, हमें ये जानना है एफडीएन कोड कैसे आया. वो कैलकुलेशन पार्ट है, वो मैं आपको बाद में बताऊंगा. ओके.
FDN कोड मतलब जो B3
हाँ,
कोड
B3 कैसा आया? बी नहीं, एफडीएन कोड वो नहीं है. एफडीएन कोड क्या है? वो B3 तो कोड नेम है. एफडीएन कोड इज द सेंस दिस वन, this 115120, how it came, and this has a meaning. Okay, what do you mean by one? Why we are taking only one, and how it is coming over here too, and why it is 2 and 5? It has a meaning. Okay,
Okay.
this code has a meaning, so we have to see that. On this only the mass type will also depend. Can you interrelate with each other? You need to interrelate. Okay.
Okay.
अभी क्या बोला मैंने आपको कि फाउंडेशन, अभी फाउंडेशन किसके ऊपर डिपेंड करेगा? जो आपका
Soil.
सॉइल टाइप है. सॉइल टाइप हुआ, फिर आपका विंड प्रेशर हुआ, और दूसरा क्या होगा आपका? वर्टिकल लोड.
Okay.
आपको लोड कैलकुलेशन भी तो करना है ना. मैं वही बोल रहा था आपको कि ये एफडीएन कोड जो है ये आपका लोड कैलकुलेशन के ऊपर रहेगा, मास्ट का. तो वो मैं आपको आफ्टर दिस 1 और 2 सेशन के बाद में, क्योंकि अभी तो बस हम इंट्रोडक्टरी पढ़ रहे हैं, सो थ्योरी है ये सिर्फ. इसके बाद में जो आएगा वो कैलकुलेशन में आएगा. वर्टिकल लोड, why we are taking this foundation, so these all thing will depend on that. Okay.
Okay.
You can imagine, no, what I'm telling.
Yes.
Okay, great.
This all these things like foundation depends on soil type, wind pressure, and vertical load.
Yeah.
And on basis of this, the FDN code will be decided.
Yes, means वो foundation का code है, right? On all these things the foundation will be decided.
Okay.
FDN code means what? FDN means what? Foundation. It's
Foundation.
a foundation, short form for the foundation it is. Okay. So this is a mast. We'll learn about now mast. Okay. This is which type of mast? You can say K series mast. Okay. Why do we say it as K series mast?
The structure,
Yeah.
the
If you
inside
take,
structure.
yeah. So if you take this small, sorry. If you take this small gap into this thing, it will look like an alphabet K,
Yeah.
right? So that is the reason why it is called as a K series mast. So what it is? A single vertical post embedded in the foundation. So this is a definition. Okay.
Okay.
A single vertical post. What do you mean by mast? It is the definition given here.
Hmm.
It's a single vertical post embedded in the foundation or otherwise rigidly fixed in vertical position to support the overhead equipments. Overhead equipment means what? This
Cantilever
cantilevers,
assembly.
contact
Hmm.
wire, catenary wire, droppers, all those things, right?
Yes.
Those come into the overhead equipment. So this with cantilever, these all things I told, right? TTC and mast, portals, everything. But there are different types of mast. First is K series mast. Why it is K series? Just now I told. This is broad flanged beam. This is used in metros also. Okay,
Yes. BFP. Yeah.
BFB mast. Okay, B series also they do use it. While termination and all they do use it. We also in Indian Railway also they use it. Okay, but
Okay.
B series mast and K series mast are the same type of mast. Only why we are not using K series mast and why we are using B series mast is due to this fabrication work. You know, so much lacing is there.
Yeah.
That's the reason why we switched to the B series, because we don't want to do a fabrication work and more work time is spent on that. That's the reason why we switched to the B series, or else the size of the mast and the capacity of the mast is all same into this thing. Okay,
Okay.
this is what RSJ rolled
Roll steam joist.
joist, right? So this is also used, but in Indian Railways, we are not using this BFB and RSJ now
Okay.
because there will be coming some torsion into this thing. Okay, it's okay till metros, but not in Indian Railways. Indian Railways like high capacity things, no, uh, big mass. That's the reason why. And you know, portal. We are using this portal, but yeah, there are different types of portal. You might be aware of that, right?
Yeah.
Yeah, but how we select the portal type? Do you know?
Uh, no, like for our metro alignment, we have used two-track cantilever portal, and in
This is
depots it is four-track, five-track as well.
yeah. For if it is 4 track and 5 track, then you have to go for portals, right?
Yeah.
Yeah, but how we decide the size of the portal? Because you know, like if I'll show you in this one, give me a second, because I have to switch the screen every time. So this is a signaling part. Okay, this is track separation chart. Okay, you can see so many portals are there.
Oh, sorry. I was just trying to switch to laptop screen.
So so many types of portals are there. You can see here, right? But how will you select the type of portals? That we will learn into CSD drawing when we are doing cross section drawing, no? Okay, that time where practically we will learn how we can take which type we can take, whether N type, either BFB type portal, or this is N type, BFB type, O type is there, R type is there. See, this is O type, this is R type. R type is also there. Okay, so we will see that how the different types of portals we will have it. Okay, we have to study this full volume chart. Okay, so this all is the volume chart, part 1, part 2, part 3. Fine. So this is all we need to check. So it depends on this, the size of the portals. Okay.
Okay, sir.
Then 2 track, you know, where do we use it?
The crossovers.
Um, you can say like that, but not exactly crossovers. It should be like same elementary section, first of all. Okay. What do you mean by same elementary section?
Uh,
You cannot,
Uninsulated.
yeah, can you use over here to TTC. You cannot use here in this location, but you can use it in this location because this elementary section is different and this elementary section is different.
Yeah.
But yeah, in foreign countries they do use TTC. Only in India they are not using. I'm telling you why. What is the reason behind that? You should know like where it is used and where it is not. In foreign countries they don't mind using TTC even if it is two different elementary section. Okay.
Okay, but why is like why do we prefer that?
It's because their maintenance procedure are different than India. It's totally depending upon that maintenance procedure. Because in India, what they do, they just climb on this and they will do the maintenance thing. But that's not the thing in foreign. They will have proper guidelines
Power
for,
block.
yeah. No, power block will be there here also when they are doing for this one or this one. So that is only the thing actually behind that. That's the reason why they don't prefer TTC um, on this thing. It's only the maintenance procedure protocol that what we are following, no, for that reason only.
Okay.
So that's the reason why in Indians they will never use it, but outside they are using it. Okay,
Okay.
but how it happens, on outside railways, these two tracks are there. Fine. So if there can be some embankment over here,
Okay.
okay, might be. I'm telling about the main line things. Okay, there can be some embankment over here. Here it can be some space or some plain line. So they will not waste money into this cutting and all like this. Okay, but what they will do, they will just make one TTC over here and make it stand. Or
Okay.
else if there is a space, they can do it like single mast also. But they will do it in this way only. Okay. So this is another type of mast. This is gantry mast. So this can be in the feeding post or section post, sectioning, subsectioning, paralleling post. Okay.
Okay.
So this can be over here. But yeah, we will learn about this drawing also, how to make this drawing in our power supply type area. Okay. We will see how we have to do the drawing for this one because we have to submit drawing for this thing also. Okay.
Okay. This is for FP location.
FP feeding post. That's what I told. No?
Yeah.
Feeding post or sectioning post. Also, this gantry mast will be there. Okay. It will be in subsectioning SSP location also. It will be. Okay. This is 80 mast, T series mast. It is called as. Okay. And here the auto transformers are there. For what we use this auto transformer?
Auto transformers. Or
Hmm. 80 auxiliary transformers, you can say. Okay. Auxiliary transformer, not auto transformer, auxiliary transformer.
actually, I have no idea
Uh,
auxiliary
yeah.
transformer.
So what happens, our station lightings, right? Our
Okay.
station lightings, our station elevators. Okay.
Okay.
So
Okay,
this
like
all
in
works on that.
metros, we have
Yeah.
that auxiliary ASS, so it's
ASS
basically
substations.
like that.
Yeah. Yeah. Basically, it is like that. What they do here is that here stations will be a little bit far away. So one 80 they will give 25 kVA 80 they will give.
Okay.
What they will do, they will tap it from the main line and they will step down to 440 volt or 230 volt, whatever they need voltage for. Fine. And they will supply it to them. Okay.
Okay, this is like railway arrangement.
Railway arrangement. All right. In the metro, what it happens is like they will have one 80 ASS substation. From there, they
Yeah.
will supply it to 3, 4 places.
Yes.
Okay.
Right.
So like that it happened. But here it is not possible like that because stations are very far.
Yeah,
Okay,
the
like
distance
five
is
ten
very.
kilometers distance is very far. So they will just put one transformers over there and they will do the tapping.
Okay. So this tapping is required where like this supply goes where it goes to the stations.
Station areas. Okay, nearby station only they will do it. And
Okay.
second thing is that in there is a problem of level crossing also here. Okay, so see, this problem is not there in metro, but here it is there. But level crossing sometimes it can be out of the radius of more than 2 kilometers from the station area. Okay, but there also the gate has to be manned, no?
Yeah.
Yeah, so for that reason they also need the supply. Okay,
Okay.
that is the why you need separate AT for level crossing gate if it is more than 2 kilometers from any end of the station. Okay,
Okay. Like like the distance which it can cover is like maximum 2 kilometers.
the maximum 2 kilometers they do it. Okay, so that's the reason why when there is a station like this, they will have a two AT system. One will be on the upper main line, tapping from the upper main line. One will be in the tapping from the down main line. Okay, so that one will be working and one will be in the standby always. And this is two-track cantilever. In yards, siding when the mast cannot be erected near the track to be equipped, it may be erected spanning one or two tracks. This is one track, two tracks, and somewhere here because of this turnout is there. Here it is two tracks. Okay, some three tracks over here. So it can extend up to the 10.5 meters. Okay, from this upright, it can go till 10.5 meters. But yeah, we have done till 11.5 meters also. Okay, because this boom can be of 8 meters. So
Okay.
8 and this cantilever can go up to 3.5 meters.
Okay.
So 8 plus 3.5, how much it will become? 9, 10, 11.5. So we do
Okay.
it. We do go till 11.5. But why they have given 10.5 is like for some safety reasons. Okay, because it's preferred that this hook should not come till edge. If we will do for 11.5, it will come till here. But it is expected that at least zero point 0.5 meters should be there. So comfortably you can go till 11 meters. Okay.
But the boom length is 8 meters
Yeah,
maximum.
yeah, maximum 8 meters. So we have two types of boom length, 5.5 meters also and 8 meters also. So it depends like how much far you need to hold it. According to that, you have to select the boom length. Simply why we will waste the metal, no?
And
5.5,
sudden in
5,
a
7.5.
case of 4 track or 5 track cantilever, that time to like this structure is like a L-shaped structure.
Mm-hmm.
So in 4 and 5 type, it will be a complete U-shaped structure, right? Like,
That is called portals.
acha, okay, okay, that is total.
Okay. That we discussed here, no? This
Yeah,
will.
yeah.
So some like there are lots of bridges like in Virar. If you go to from Mumbai to Surat, or you can see big bridges over there. Okay, so on bridges, how will you do? You will have this base plate, and this is gusset plate. So you will have this bolts on this plates. Okay, this system we use it in metro also now. Okay, same thing. How what we use
Yeah.
it in the bridges, it's use it in the viaduct.
Yes. U-bolt
Uh,
arrangement.
yeah, you. So this arrangement we do it over there also. But yeah, here also many things comes into the picture. The loading of this base plate, the diameter of this width of this base plate, the thickness of this base plate, all it depends on that. Okay. This is overhead equipment. The electrical conductors. What is overhead? The definition has been given over here. The electrical conductors over the track together with their associate fittings, insulators and other attachments by means of which they are suspended and registered in position. All overhead electrical equipment, distribution line, transmission line, and feeder may be collectively referred to as overhead lines. Overhead line किसको बोलते हैं वो इसमें लिखा है. Collectively referred as overhead lines. This is cantilever assembly. Okay. It is an insulated. Okay. This is insulation is there, right?
Hmm.
And it's a swiveling type structural member. Swiveling means what? It can move left and right. Right? It's not fixed. It is swiveling. It can move left and right. Why?
Okay.
Why it has been kept in that way?
For pantograph movement, because of
No,
pantograph.
not like that. For pantograph, what it can be? I'm telling like left and right, not up and down. Pantograph effect will be up and down, right?
Wind, because of the.
No, no, no. There is a terminology called as a drag factor in the wire. There will be a drag factor.
Drag factor.
Yeah, drag factor. Okay. So what happens, like uh, during this what you say summertime or winter time, the expansion and contraction of the wire will take place, right?
Yeah.
So when this expansion and contraction of the wire will take place, we do have ATDs, auto tensioning device, to make
Yes.
sure that there will be no sag.
Yeah.
But you during this pulling and contraction, expansion and contraction, this will move, right?
Yes.
For that reason only, this cantilever also has to move. So every time it will have some deflection by some angle. It won't be always straight. If you see from the top, it will have some deflection. Okay.
Okay. So it moves back and forth, or
Yeah, left and right, I mean. Okay. So imagine yourself like you are holding this wire, okay, and from in the center, fine, and I am trying to pull that wire left and right. So how will it happen to your hand? It will also move left and right, right?
yeah.
But if you make it very stiff, there's a possibility that it can break over here or it can bend also. So that's the reason why this movable swiveling it has been kept. So I'm just telling the why this word came swiveling. Okay. Yeah.
Okay.
So this is the cantilever assembly. What basically typical ideal cantilever assembly, whatever you can say it. Okay. This is the mast. This is a hook fitting. This is insulators. This is stay tube. This is adjuster, and this is a bracket tube. Okay. Why we need adjuster over here? The word itself says it adjusts something, right?
Yeah.
What it adjusts?
For the stagger arrangement.
Um, Stagger we give for contact wire, no?
Okay.
Contact
The
wire is here, but why we do need arrangement over here? But yeah, again one thing in Indian Railways, what happened in Indian Railways or Indian metros? What happened is that they give stagger for this one only, but they don't give stagger for this one. This is always kept at zero. But in foreign countries, how it happens? They give staggering for both. Okay.
okay.
But in Indian Railways also they give for both. If the distance between these two is more than 200, then we will make sure that it comes parallel to this one. Okay.
Okay.
So this is some little small differences are there. So I will tell you, just keep this in mind anytime. So yeah, I was in this adjuster. Why we need this?
for the like to arrange the arm of the
Sorry, which arm you want to say?
yeah
It's bracket
this
tube.
yeah bracket tube.
But why we need that?
Uh, to maintain the uh, encumbrance distance.
No, encumbrance will be maintained here. Encumbrance is maintained. Encumbrance doesn't affect this one. Encumbrance will be done through this one. Here there is one clamp, right? Catenary suspension clamp is there. Say, if you
Yeah.
move this one here and there, up you go, encumbrance will be more. Down you go, encumbrance will be less. Or else you can change the angle of this one, right? I gave you the answer. If you will move this adjuster, the angle will be changed.
Okay.
And if the angle is changed, this catenary wire, you can see it is at the center line of the track.
Yes.
So what happens sometimes is that the track maintenance is there. Okay, we have a packing machine, no, big. In the depot also you will have some packing machines, or I don't know, depot is very small, uh, but how they will do it. But they have a packing machine. Sometimes what happen during the maintenance time, the track will need to sleeve itself. What do you mean by sleeving?
No, sleeve track will sleeve itself.
Yeah, track will sleeve. No, we sleeve the track during the maintenance. Sometimes it happens.
Okay.
It's like sleeving means what? ये अपने जगह पे अभी फिलहाल है, पर मेंटेनेंस के बाद कुछ हट सकता है by some or some centimeter. मतलब ऐसा कुछ फीट या किलोमीटर में नहीं होगा, कुछ में होगा बस. ओके,
Okay.
तो उस समय में हमें ये एडजस्ट करना होता है कि ये अपना ट्रैक सेंटर पे आए. ओके, तभी ये भी एडजस्ट होगा, स्टैगरिंग भी.
Okay.
क्योंकि क्यों? क्योंकि ले अगर हम ये एडजस्ट नहीं किया, चांसेस हो सकता है कि ये पेंटोग्राफ छोड़ दे कांटेक्ट. देयर कैन बी अ चांसेस. सो दे विल verify this thing. So when there is a track maintenance, behind the track maintainer, the OHG people, they will also take that tower wagon and go and check the staggers. And if it is not there proper, they will make sure that they will change it. This is all in the maintenance thing. Okay.
Sleeve of track. I mean, I didn't get it. Like what? Like the center of track changes. What do
Yeah,
you mean?
center of track can change. It can change in okay, millimeters.
Because of the track maintenance.
Track maintenance, sometimes they will sleeve it. Or else it can be the other thing way around also. Like for example, here two tracks are there, one more track is there, or they want to put one more track, so they might change little bit, they might shift the track here and there little bit. Okay,
Okay.
so at that point of time also this will come into the picture. This will just give the margin, instead of changing the whole cantilever, they will just use this as an adjuster.
Okay.
Okay, to make sure that this is at the center.
So this adjuster is basically used to adjust the suspension bracket.
Catenary wire, so that it will be at the center line of the track.
Okay.
Okay. So this you can see there can be maximum 3 cantilevers, okay,
Yeah.
on one mast. But here you can see no wire is on the same height. Am I
Yes.
right? Yeah. So that engineering we need to learn. That's what I just wanted to say you. Okay. So that is where the engineering comes. How to keep the wire at proper height. Okay. So that is the main concept of our learning. Because pantograph is very sensitive. if any wire gets stuck into the pantograph. I don't know whether you have seen this video or not. Can you see the video?
Yeah.
See, this can happen.
Okay.
So it can even pull the wire down.
Okay. This is because the pantograph got stuck with the wire.
Wire. So that's what I told, no? That engineering should be proper when the height of the conductor.
Okay.
See how it broke everything and fell. It's a huge cost now. See the cantilevers and all, how it is broken. So you know the seriousness of this thing, right? How careful we need to be when we are designing it and when we are installing this. Okay. So there are some special box. This is also called as a cut DA. This is a drop arm, right? DA means drop arm. This is a
Yes.
big drop arm. It will be of 3 meters somewhere around. But in the special box type cantilever, this is called as a box type cantilever, where it is used where the track center, this is TC, this is track clearance, also we can say, or track center, both are same. Okay. The track center for this line and this line, this track is less than 4.2 meter. There we are using this thing as a cut DA. Because we cannot use this bigger one, it can come into interference of the train, because train
Okay.
is crossing, no, here it's coming from this line and meeting up at this line. Can you see? So it can be an interference for the train. That's the reason why they're using it as cut here.
This is used on main line also or only depots? Okay.
No, everywhere, mainland depots, everywhere, wherever the clearance is less than 4.2 meters. Okay, this is stay arm. The size of this you can see. Okay, give me a second, I will be back. Okay, in a second I will be back. Okay. Hello, hello.
Hello.
Yeah. So this is stay arm. The size of this stay arm you can see here. So what
Yes.
this means 28.4 by 33.7. What does this tell?
History. Cube. Cube.
No, what does this mean actually?
The diameter of the rod.
Okay, but why two? It's like inner diameter and the outer diameter because this will be the hollow steel.
Okay. Okay.
Yeah, you can see this adjuster, no, here.
Yeah.
Just spoke about this is the adjuster. So this will mostly assure the angle of this bracket. Okay, are you getting it?
Oh, yes.
Okay, great. So this is a bracket tube. You can see the size of this tube. There are two types, but we mostly go for the large type only because more load it can take.
Okay.
Third thing is that it comprises of register arm 28.4 and 33.7, and this is a steady arm. So this is like a shock absorb in your bike or scooty will be there, right? So the pantograph will be pushing up the wire. So this will go up, down, up, down. It will happen like this. This will be the anti-wind clamp. So due
Okay.
to the wind, this should not have any effect. So this is called as an anti-wind clamp.
That
Right?
this remains constant. Only the
Yeah.
steady arm keeps on.
Yeah, yeah. This will remain constant. No? So all the shock absorb thing it is taking place here.
Okay.
Okay.
So basically, the adjuster above is to adjust the bracket tube.
Yeah. So this is steady arm assembly. So it is 32 by 32 BFB section made of aluminum alloy. Okay, contact wire to require staggering purpose and to take the push up of the contact wire. That's what I told. No, it will go up and down, push up.
Yeah.
So it will be always in tension. So this is portals. So you know where portal is been done. I explained just now.
Yeah.
Okay. These are some insulators: stay arm insulators, porcelain insulator, and composite tie insulators.
There are synthetic also.
Composite only. It is called the same thing, synthetic or composite. Okay, so what happens is that composite we use in the polluted area.
Yeah.
And this is a bracket tube insulator. This is porcelain and composite. Same thing it will be for bracket. And this is a 9-ton insulator. So this is used for where we are anchoring. Okay. Hello.
Hello. Yeah.
So where we anchor it, there we have to use a 9-ton insulator. Okay,
Okay.
great. This is post insulator where we are
Is
using it. Yeah, we are using it in the gantry mast and all.
okay.
There we are using this thing. This is section insulator, right? You know this section insulator, right? In the loop line or something where we want to have two different elementary section, there we will use this thing. So this is what the design load it is. Okay, and this is the test load at 70%.
Okay.
So what happens here is that uh, the design load and the test load, like it is just 70% only we are using it in our practical way. So that's the reason why it is 9 ton, because 9,900 kgs it is. It can hold design. It is designed to hold that much. That's the reason why it is called as 9 ton. Okay.
Okay.
Encumbrance. What do you mean by encumbrance? I hope so. You know this encumbrance, right?
Yeah, yeah, yes.
Distance. So how much it should be in railways or in metros?
Metros it is 1.2,
1.2.
1.2 to 1.6.
1.2 to 1.6. But general condition, I'm telling, normal condition,
1.2.
1.2. Then when they do use 1.6, then
Curve area.
sorry,
Whenever there is curve or something on the alignment.
curve.
Yeah.
Okay. So they do use for 1.6.
Yes.
Okay. Right. So here it is like in see, like metro they are using 1.2. In Canada or UK or Australia, somewhere they are using like 1.3 also. Okay. And here they are using it as 1.4 in Indian Railways. So it's just like some differences there, but encumbrance is called as encumbrance only. Okay.
Okay.
So it's just depends on the thing, other factors also. So yeah, this is a span under the overline structure. I will tell you that later. Overline structure means what? If there is an over bridge somewhere, if there is a bridge above the railway track, for that condition it is. But we have to do the calculation also. We just cannot go by this sheet every time. So this is how it looks like: catenary, dropper, and assembly. It's assembly, contact wire assembly. You can see 65 square catenary wire, 107 square contact wire, and this is a dropper. This is 105. Variables are here. Okay, and this is a dropper of 5 This is a contact wire dropper clip, and this is 25.5 Everything is in Okay, and this is the reference drawing number. From that it has been taken.
This
So the,
is like
yeah,
this is general arrangement.
yeah, how the catenary and the contact wire arrangement will take place. So this will be a stranded wire, okay, and this will be the hard drawn wire.
Okay. The distances are
This distance you want to know?
uh,
It will vary. I'll show you how it varies. Can you see here? Our contact wire is same. Our catenary wire is in U shape. So this distance will vary, right?
hmm.
Everywhere it go. It will not be same. So that comes into the dropper calculation.
Okay, dropper schedule.
Dropper schedule and dropper calculations. Fine. So this is the dropper fitting, how it fits. They fit it.
Okay, so
Because all
the
the yeah, its work is like, first of all, remove the sag from the contact wire and transfer it to the catenary wire. Okay, all the sag is transferred to the catenary wire. So
so
are you
the
getting it?
dropper distance is calculated like the within a span length, like the picture which you showed. Yeah, this distance is constant or it changes according to the site conditions.
It is
Lines.
in Indian Railway. It is constant. Metro also it is fine, the same thing. But this is not the scenario in foreign railways.
Okay.
So there it differs, like according to the span. There they don't have the span. See here, like in metros also you might have seen, no? the span will differ in the interval of 4.5
Yeah.
meters. Yeah, in Indian Railway also it happens, but this is not the scenario of 4.5 concept outside. It can be like, for example, here how if you are having 36-meter span, so next span can be of 40.5 if you want to increase the span, right? Am I right?
Yes, yes.
But this is not the thing in when you go for the foreign railways. You can use 38-meter also. But only the condition in the foreign railways while designing is that you should not have the same consecutive span for five. For you should not have a same span for 5 consecutive. Okay, same span मतलब 1 2 3 4 5. अगर 5 स्पैन है आपका तो पांचों स्पैन सेम नहीं रहना चाहिए. ओके, द सिक्स्थ स्पैन आपका अलग होना चाहिए.
Okay.
That is one condition it is told, and it is same thing over here also in Indian Railways also, that they don't allow more than 5 span to be the same, or else the maximum span, हमारा maximum span कितना होता है, 72 meters होता है, right? तो you cannot keep 72 meters just in a long way. Okay, you just cannot keep like that. They don't allow. You have to vary the spans.
Okay.
Because there is a reason behind that why you need to vary it, because sometimes the mast can fall, so you have to place another mast, right, at some distance, so the maximum span will get increased at one location, so that should not happen. For that reason only it has been told it should be in the schedule, right?
Okay, so this arrangement is typically for one span. Like
Yeah,
this,
this is
will
one
it be?
span only. Yeah, like this it can be n number of spans. Okay. So it is typically here told as the distance between the droppers should be 9 meters. Okay, but the first dropper has to be of 2.25 meters. The next dropper here can be of C, that is 6.75 or 9 meters, but rest all will be 9999 meters. And this will depend upon the span length. Okay, here you can see how many droppers will be there. So if anyone will ask you immediately for 45-meter span, how much droppers? So how will you tell? Six
Six.
dropper? No, but you don't have the sheet. No. So what you should do is that 9 divided by 45. 9 into 5 multiplied by 5 is 45, right?
Yeah.
Plus 1 you should do always. If it is exactly multiplying, plus 1. Okay, so next number will be what coming? 9 6 are 54.
Yeah.
Right? So that time you should do plus 1, and 58.5 is not dividable, no? So it is 7 only. Next number is divisible by only 63. So that's called as plus 1. So like that you should remember, okay? And this is like typical length of the dropper, which is called. Second thing is that height of the contact wire, the distance from the rail level to the underside of the contact wire, okay? This is called as a height of the contact wire. So you should have come known till now that we are, for us the reference is track. As I told for the cantilever also, this should be center of the track. The height should be from the rail level to the underneath of the contact wire. Okay, hello.
Yes, sir.
Yeah, so this should be, the reference is taken from the track itself. Okay.
So one doubt I had, like the previous, like the dropper schedule, like the if we use the multiple droppers, like So how will we maintain the encumbrance like here?
Encumbrance is maintained and considered only at the support, not at the mid span of the span.
Okay.
At the support, you can see 1.4 meters. At the support only it is considered.
Okay.
And
I
why?
mean start and end of the span.
Yeah, start and end of the span. Why it is considered? Because we should make sure that this wire, okay, this wire is used for pre-sag. You know, pre-sag. Sag means what? This will be the sag. No, if you don't put this one and only keep this one, this will become little more sag. That is the way. That is the why tramway wire is not used for high speed in depot and all. For some lanes, for some lanes they use tramway wire, but
Hmm.
not for the lane of testing line. Okay,
Test track. Hmm.
test track, testing line or test track. They don't use tramway wire there. They use this flexible wire, right?
Okay.
Are you getting my point? Why? Because test track, the it is a testing thing. No, there they will use this wire so that the speed will be there. In tramway wire, only one wire will be there. So there the sag will be more. That's the reason why you cannot speed restriction will come.
Yeah.
Fine. So that is the reason why we use this one, so that our sag is compensated through these droppers and it goes up. Our encumbrance is only at the support. This can vary again. It doesn't need to be same every time. Okay, 1.4, 1.4. Here it can be 1.4, here it can be 1.2 also. As you only told, right? In metro, it varies from 1.2 to 1.6, right? At this position, it can be 1.2. At this position, it can be 1.3. At that location, everything will change. Here you can see the symmetry, right? D1, D1, D2, D2, D3, D3, D4, D4. But there, if you change the encumbrance at one end, no symmetry. All the wire droppers will be of different length then. So there the schedule will come. Proper schedule, proper calculation, and then you have to present a calculation chart and tell that at this span this wire dropper has to be at this. So we will see that calculation. No problem. Just for you to tell.
So the dropper length is decided based on the calculations.
Encumbrance. Yeah. Calculation also and encumbrance. Okay. So I think so. What's the time?
6:11.
6:11. So you need to stop or you want to continue?
6:30. We can continue
6:30.
to 6:30. Yeah.
Okay. I okay. Just skip for charging. Okay, like for 10-15 minutes we'll kind of continue. We'll go till this point. Till here. Till here. It will be fine because this will be a new chapter, you can say, and we can continue from there next time. Okay. I hope so. You are getting some interest into this learning, right?
Yes, sir.
Or am I demotivating you?
No, no, no.
Okay, great. Let me know. I will motivate you again. Okay. So this is what height of the contact wire. At support point, it should be 5.6 meter. Okay. And pre-sag of 100 mm. At support point, it should be of 5.5 meter, pre-sag of 50 mm. At local connection pit, it should be of 5.80 meter. At level crossing, it should be of 5.5 meter. So this is the um, what you say? Uh, what you say? Uh, rule or what you say that I forgot the word.
Clearance.
Yeah, clearances or rules or that thing. It is called as. In metro, the height of the contact wire will be less. Okay, it is around 5.1 or 5.2. It will be right.
5.5.
5.5. Are you sure?
Uh,
No, no, not
uh,
5.5. It will be of 5.1 or 5.2. It will be 5.1 only. It will be okay. Because our metro train, this ODC is small, no? Over-dimensional consignment. It will not be as big as this one, railways or local train, right?
yeah.
Because our gauge is also smaller there,
Hmm.
right? How much it will be? 1.432.
Yeah.
Okay. Here it will be how much? 1.676. So the gauge difference is there. But the concepts and all are same, but that's the reason why the height will also be reduced here. So in foreign metros also, what they do is that our contact wire height will be at 4.8 meter or 4.7 meters,
Okay.
like that it will be. But their level crossing, if they have a level crossing, they will make sure that the wire goes up to 5.5 meters.
Okay.
This will be same. Okay.
So here, metros, so there won't be level crossing.
No, no level crossing. No. There is
Only
no. Yeah.
depot. If
Depot also no. Depot also they will make sure that it will be of 5.5 meters height. Okay. Minimum. In depot they have to give 5.5 meters high. Okay.
only on the mainland it will be 5.1 or 5.2.
Yeah. Because safety reason, no. In
Yeah.
depot and all, what they do, they carry met something and all, like some truck will be there going around the line or footpath. Okay. So that all things will be there. Staggering. Why we need staggering?
To make for smooth functioning of pantograph.
Okay, but why you need smooth functioning of the pantograph?
Uh,
No, I think so. It's okay. I'm making you to think. Okay.
yeah, yeah.
Uh,
Because uh, like there won't be any current collection at a point.
no, what happens? Like if you try to have a contact with the pantograph at only one location. Okay. Yeah. If you will try to have a contact with the conductor at only one location, so after some time this will get cut.
Ah, yeah, yeah.
So they will have a full carbon strip over here. So zigzag it will go, and this will
Yes.
increase the life of the panto.
Huh.
That is the reason why we need staggering. So how much is the staggering we are using for? 200 mm plus or minus 200 mm. Okay, on the straight line, and 300 mm on the curve.
Curve. Yeah. So this staggering is it is it all depends upon the cantilever assembly, right? How we assemble the cantilever. Then when the time of operations, it just goes in line, or we need the adjustment. Like
We will have
how?
to do the adjustment, no? So how it happens, when it is a straight line, so one will be minus, one will be plus, minus
Yeah.
plus, minus plus, it will be there. So like this, we arrange it, we will assemble it. So this is the how it looks like if it is a minus, and this is how it looks like if it is a plus.
Okay.
Okay, so minus plus, it will happen one after the other like this.
Okay. So the cantilever assembly, we have to make it assemble like that, plus and minus, like.
Minus plus and minus in the straight line. But in the curve, what you do is that if it is an inside curve and outside curve,
Hmm.
are you aware of this terminology?
Yeah.
Okay, so if it is an inside curve, so you have to do it the staggering to the opposite side.
Okay, because train will go like more on the curve will be more steep
Curve
inside.
will be more steep inside, and you have to do it, pull it to the opposite side. Okay, so it has to have some cant deflections will be there, pento deflections, cant will be there, super elevation, what you call. Okay, so if you don't know, let me know. We will discuss on this in the deeper thing in the coming like days. No problem with that. You can just tell me that you don't know. I will tell you. Fine.
Okay. Like the term which you use, like the can't will be there, means exactly what you mean.
Cant will be there means what? The track will not be like this. One track will be up and one track will be down. One wheel
Okay,
will
you
be
mean
down, one track will
gradient.
just no, not gradient. Gradient is different again. Gradient means what? Slope.
Slow. हाँ.
Slope. अगर आप खंडाला घाट को चढ़ना है तो मुंबई से चढ़ रहे हो तो कैसा होगा? स्लोप होगा ना? That is
हाँ.
called gradient.
Okay.
In curve, it is not a gradient. It is called as a super elevation
Super elevation. Okay,
or
and then the
else
one
cant.
one track is up and another track is
Yeah, one
down,
track
like
is
that.
up and another track is down. So it is in the curve only. So when you are riding bicycle, you might have drove the bicycle or bike.
Hmm.
Okay. So when you are like गेट से बाहर निकल रहे हो और कर्व कर रहे हो, टर्न कर रहे हो, तो you will bend on one side, no, according to your speed.
Yeah.
This is what it is happening. The physics concept to counter the centrifugal force.
Hmm.
This is what happening here
Okay.
for the train. So according to the speed, they will have the cant over here. So this is a track department. We don't have to bother. They will give us the cant. According to that, we have to make sure that our this should be there. Contact wire. We have to make sure or it should be according to that. And we have to make sure that pento deflection what it is. Okay. Are you able to line it up?
Can't means exactly what the calculate track. It is related to track.
Yeah, it's related to the track. So one track will be over here, another track will be over here for the curve like this, and one track will be over here, one track will be over here for the curve in this way.
Yeah. Okay.
Okay, are you getting it?
Yes. Yes. Yes.